Hi everybody, we are going to now talk about factoring a quadratic trinomial here, or the quadratic function. And it's a very straightforward step-by-step process. And I will kind of go through that process with you. Let's start with this function. F of x is equal to 2x squared plus 5x plus 2. Now, it doesn't matter what numbers you have. It's going to work for any one of these. The first thing you have to do, though, is you have to say, okay, can I factor out a common factor of the coefficients? That's your first question. You look at the 2, you look at the 5 and the 2. Can you find a common factor that divides into 2, divides into 4, or excuse me, 5, or into 2 without leaving a remainder? And then in this case, no, we can't. So step 2 is we need to take a times c. So we need to look at our function above here. A is a 2. And c is a 2, so we'll get 4 as our answer. Now step 3 is we need two numbers that multiply together to get to be equal to a times c, which in this case is equal to 4. So do I know two numbers that can multiply to 4? But those same two numbers, you have to add them, in this case to get 5, which is actually equal to your b. So I need two numbers that multiply to get the 4, and I can add them to be 5. Now, you can write this down if you want to. 1 times 4 is 4, or 2 times 2 is 4. If I look at this and examine it, 1 times 4 is 4. 1 plus 4 is 5. One times 4 is equal to 4. 1 plus 4 is equal to 5. So those are our numbers. I'm going to create a box now. And what I'm going to do is, in this box, I'm going to put my ax squared, which is 2x squared. In this box over here, I'm going to put my c value, which is 2. That's my c. And then now, since I have a 1 and a 4, what I'm going to change this, I'm going to change this to plus 1x and plus 4x. And now what I'm going to do is I'm going to factor across the rows. I need to factor the rows in columns. Now, in the top row, I look at the numbers. Can I factor out a common factor for a 2 and a 1? The only number is a 1. I have an x squared and an x. I can factor out a common factor of x. Now in the second row, since this first box is positive, this is going to be positive. I have a 4 and a 2. The common factor between 4 and 2 is a 2. So when I get x plus 2, I'm going to get the binomial x plus 2 as one of the factors. Now for here I have 2 and 4. The common factor between 2 and 4 is a 2. I have x squared and x, so I can factor out an x, so I have 2x. Now here I have a plus, it's positive, so I know I'm going to get plus here. I look at the numbers 1 and 2. I can't factor out anything except for a 1, so I'm going to have to put 2x plus 1. So that tells me that the binomial down here is 2x plus 1. So if I find f of x is equal to 2x squared plus 5x plus 2 is also equal to x plus 2 and 2x plus 1. So it's the same process over and over and over again. If the binomial can, or the quadratic trinomial can be factored, you will end up with these two binomials. And if it works, it works. If you can factor it, you'll be able to factor it using this method. Another way, let's take a look at a different problem. F of x is equal to x squared plus 16x plus 64. Alright, same thing here. I look for common factors. There's nothing, because I have a 1 there. Now, first step, I need a times c. A times c, well, this is 1 times 64, which is 64. Step 2 is I need two numbers that multiply to get to 64, that when I add them together, I get to 16. So 64 is 1 times 64, 2 times 32, 3 times nothing, 4 times, goes in there, 16, 5, 6, no, 7, no, 8 times 8. If I look at the sum here, the one that gets me to 16 is 8 times 8. 8 times 8, and 8 times 8 plus 8 is 16. Now, since a was equal to 1, we can skip the box and say that x plus 8, this first one here, times x plus 8 is equal to x squared plus 16x plus 64. Now I want to do this problem because I wanted to show you that these are the same. And these are called a double root. And we can simplify this down to x plus 8 quantity squared is equal to x squared plus 16x plus 64. And if we're on the graph, what's going to happen here is the parabola is going to hit the x-axis just once. Sorry about that. Right here at x equals negative 8. And we find that by saying x plus 8 is equal to 0, so x is equal to negative 8. And the vertex is the only thing that's on the x-axis. So when you see the graph hit only in one spot like this, or the bottom part of a hump in the graph like this, that's what we call a double root. It's in the problem twice, but it only shows up once in the graph. And that's a pretty bad picture. So this is what it would actually look like. So we have our double root that's going to hit twice, which is really, really nice. So those are a couple different problems. We've been doing this in class a couple days already, so you can take a look at how to do these. And I'll have some more videos on how to do these up shortly.